Hello, this is Tim Malloy, and I will be recording video 1-1 1D motion. I decided to choose problem 9 on the WebAssign, so I will now recite that. I will read it off. An inquisitive physics student and mountain climber climbs a 45-meter high cliff that overhangs a calm pool of water. He throws two stones vertically downward, 1 second apart, and observes that they cause a single splash. Really want to highlight that. That's a very important part of the problem. The first stone has an initial speed of negative 2.12 meters per second. Let's draw a little picture and write down our givens so far. So we know at time equals 0 seconds that stone A will be dropped with a speed of negative 2.12 meters per second, and it will drop into a pool of water 45 meters below the cliff. So y displacement, or vertical displacement rather, of negative 45 meters, because I decided to label the top of the cliff as the reference point. And we can also just write down the acceleration due to gravity, the vertical acceleration, which we can just round to negative 10 meters per second squared. And then where things get interesting, or a little bit difficult, is at time equals 1 second, where the B stone is dropped, the second stone. And you can see that this A stone has already been dropped, and we know that because of acceleration, that the velocity and the distance in between points when a object is dropped vertically will increase until it hits terminal velocity. So we're going to need to account that acceleration in for this problem. I decided to set up a little time equation here. This is going to help us out later. We can come back to it later. So part A. How long after release of the first stone do the two stones hit the water? We know the stones hit the water at the same point in time, so if we find the time for just one stone, we can find the time for the other stone. For example, let's say time B, or time A, equaled 3. 3 minus 1 equals 2 seconds for B. So I decided to use formula number 2 on the study guide for this problem. I found it was the easiest. Vertical displacement equals initial vertical displacement plus initial velocity times time plus half time plus 1/2 times acceleration times time squared. We plug in our A values, our A variables rather. It's important I call them variables. And then we plug in the values, negative 45 for the final displacement, negative 2.12 for the initial vertical velocity, our acceleration due to gravity, vertical acceleration. And then we simplify here a little bit. And then I decide to add positive 2.12 meters per second times time to both sides. So this is moved over here, and then I guess it's moved over there. You can kind of see better down there. And then I also added 5 meters per second squared times time squared to the other side as well. So then we're able to put this in our calculators and factor. I suppose you could definitely use the quadratic formula for this. That would definitely work. We want to take the positive value, because when you put everything on one side, it's TA equals 2.79 s. So TA equals 2.79 s. We can go ahead and put that in the answer box. And then once you do that online, you can see that it does give you the right answer. So we are on the right track. Everything's good. Let's go back to this. Actually, I'll read the question off first. What initial velocity must the second stone B, have if the two stones are to hit the water simultaneously? It's asking for magnitude and direction. So we know that time B equals time A minus 1, because stone B left 1 second. It left 1 second after stone A was thrown. I guess stone B was thrown 1 second after stone B was thrown. So it takes less time to cover the same amount of distance as stone A, like I have here. And yes, we are going to need to solve for this initial b velocity, and then we're going to use the time of b to get that. So 2.79 s minus, oh, I'm sorry, I'm getting ahead of myself. I'll write this with the pen. So TB equals 2.79s minus 1s, should put s there. It's important that we use units. Time b equals 1.79, whoops, 1.79s. Stones meet at the splash, or the same point, Let's calculate using that point. So that means that our final displacement will once again be negative 45 meters. So we're going to, for the sake of understanding, set up two equations that are equal to each other, since both equations should equal negative 45 meters. So this formula number 2, I made a version where I plugged in the a values, for the a variables, and then a version where I plugged in the b variables. Set them equal to each other because, once again, they both equal the negative 45 meters of vertical displacement. Here's everything we know plugged in minus the time. Here's everything, all the values we have plugged in, including the time. Again, leaves earlier than b. And then since we know everything equals negative 45, I did not solve this part of the equation. But if you do, you will see that it equals negative 45. So we just move that down here. I shouldn't have said I didn't solve it. I did solve it, and I saw that it equals negative 45 meters. I just didn't feel the need to write it out. And then for B, we simplify negative 45 meters equals 1.79 s seconds times the initial b velocity minus 16.02 m. We do that, and then we get we simplify, and we get a final answer of negative 16.19 meters per second, which you'll notice is much greater than our initial a velocity, because it kind of has to catch up because it has less time to reach the same point as the a stone, as the first stone. So we'll plug in just the magnitude in this box, and we'll plug in the direction, which is negative or downwards, in this box. So finally, we can move on to part C, which I think is the easiest part, because part B is really understanding the relationship between the two stones. And I think setting up two equations like this is really good for the sake of understanding. So far in AP Physics, I've kind of realized that this second equation, this kinematic right here, is kind of it's the most important kinematic, at least for this year. Last year, I'm not quite sure. I remember using them all a fair amount, but this year, formula number 2 absolutely takes the king. Let's move on to part C. What is the speed of each stone at the instant the two stones hit the water? So basically, what is the final velocity of each stone? We can use the first formula on the AP sheet. Final velocity equals initial velocity. I'll go ahead and put a little mark over that. I always like doing that. Plus the acceleration times time. I made a version with the a variables, version with the b variables. We plug in our values, and then we understand that final velocity of A is negative 30.02 meters per second. And then the final answer for the final velocity for B, the B stone, is negative 34.09 meters per second. You'll notice that the question does not ask for the direction, so make sure you leave that negative out of your answer. And that's pretty much it for this question. Thank you for watching, and hope this helped.